call. Today is our 117th meeting. So we've doing this a while, and what I'll put on the screen here is our last meeting minutes. I'm hoping you guys can see my screen.
Yep.
Can you see? Yeah, okay,
can.
great. And so great. So yeah, just we had a combo dash community and behavioral model meetings last week. So I combined those and usually just give a summary for the folks who do not want to read the whole thing, and talked about the contribution from AMD and the contribution from Microsoft about the data playing app. So, and then I talk about what we talked about in the behavioral model with the concern around test performance limitations and ideas to address them. And just for anyone new on the call, that's the top of the fold. And then if you really want to get into the details about what we talked about, this is our project list in GitHub of things we're working on and where we are and things we talked about in the call specifically, and links to the YouTube videos down here. So if you miss it and want to go watch the YouTube videos, these are the links right here. So if you like, just let me know in the chat window if you'd like to receive these communications, and I can add you to the list. So it looks like today, let me size this down a little bit. Like I said, I'm working off of one monitor, so I apologize. But it looks like we had a couple of new things get added into the queue. Specifically, we have the Dash Express Route Gateway Bypass HLD. And so let's take a look at that one. Or I should ask, does anyone want to talk about a PRR issue first before we get started? I'll take that as a no. So it looks like this HLD talks about the Dash pipeline for Express Route Gateway. So if I can't see very well, if Riff is on the line or Mukesh, or no, not
Yep,
Mukesh.
I'm here.
Oh, sorry, go ahead, Riff. Did you
Yeah,
want to
no problem.
present or do you want me to keep presenting?
Yeah, I can present. And so,
Okay, I'll
yep.
stop. Okay.
Thank you.
And anyone new, if you have questions or anything in the call, you're encouraged to go ahead and ask. Thanks, Riff.
Yeah, no problem.
Mm-hmm.
Okay, can you all see my screen now?
Yes, I can. Mm-hmm.
All right. So basically, this is the Dash Express Route Gateway bypass. Then we were talking about for a while. So this one, this HLD itself, it only talks about the gateway bypass part. So some of it actually involves like private link service, those things. So we when reading this HLD, the first thing is that we might need to get a sense of the private link energy, just like previous readings. So we actually do have one, if I remember correctly, for the private link service. So if, yep, so like this one. So if anyone is not familiar with private link energy, this HLD will have like more details. We also have the link in the end of the reference, if I remember correctly. Oops, not with the HLD, I'll add it later. Okay. All right. So just a little bit of background, and of course, the first thing is all this like terminology. Sometimes you'll see like the short like acronyms, and this is what does this acronyms actually means. All right. So background is that we will have the private link actually provides like one-to-one VNet mapping to the customer's like private service, and in this case, for Express Route, which is actually on-prem networks, so those this feature is also added there, which means that we will also like support the traffic coming from the on-prem network, and so the on-prem network it has a gateway, and then gateway will traffic will be handled by the smart switch or Dash pipeline today. That is why the design is called Express Route Gateway Bypass. And how it works in the data path from the packet transformation perspective is that the packet the transformation is almost identical to private link. So this is a private link. This is a VM to private link service. So you can see the traffic is almost identical. So the email packet will be transformed from IPv4 to IPv6 with a prefix, while the outer packet, the underlay packet, will be like changed from the outbound side of the tunnel or the VM side of the tunnel into the GRE the GRE cap, which is used for the private link. So on the left side is either Express Route or MSE, while the MSE means Microsoft Enterprise Edge. And then this on the left side will be using a VXLAN cap, while on the right side will be using the GRE cap. All right, and then the return path. Let me highlight the difference between the gateway bypass and the private link. So the packets that the packet that's in the gateway bypass scenario, the two things are different here. The first thing is that the MAC address that is coming from the gateway, and coming from the MSE, instead of having a source IP, instead of having the source MAC as the -ENI MAC, they will have the destination MAC as the -ENI MAC.
Does it ARP for it? Has it ARPed for it somehow, or?
It's not actually ARP, but it's
Okay.
just like it's just like
But
the
it
packet
obtains it.
sends. Yep. So that makes the outbound side of the traffic and inbound side of the traffic both using the destination MAC as the EN MAC. So this is the first thing that's different. The second thing that is different is in the return path. So in the return path, the incoming packet will still be like GRE incapped packet that's coming from the private link service or private link endpoint. And then inner packet or overlay will be transformed back from IPv6 to IPv4. So looking like this. However, in the reverse side, the return packet goes back to the MSE. So here, we can see the two IPs are different. The one IP is different. It's actually this one, the VXLAN, the source IP. So the source IP will be a different IP that is a special IP that is different from the smart switch like data plan VIP, which usually we use the data plan VIP as a source IP, but here the source IP was different. That means that the pipeline needs to have a way to change the source IP. So that is another thing that is different. Okay, so overall, the only two things: the destination MAC and in the incoming packet, and the source IP, source underlay IP in the return path. All right, then on top of that, it also supports like private link NSG. However, the NSG will be just have another NSG in cap, and this will be exactly the same as how it works in private link. So I'm going to omit that here now. Okay, so then how data path works. It also supports fast path. Fast path is exactly the same. The reset at a timeout is also not required. Then that means that if anyone is interested in, feel free to look into like the load balancer fast path support here. Okay, so I'm going to open that as well. All right. Then talking about like resource modeling requirement. So basically, the scaling requirement is actually pretty much the same. However, we have a few lines not filled here. We are still working on that, so I will share the details afterwards. Right. Reliability. So this one also needs a flow replication, and and we also talk about some special requirement on the flow resimulation part, and that is actually the same as the private link as well. So we'll talk about them very soon. Okay. So, and this one, remember, we have it somewhere here on the flow resimulation. Yeah, maybe it's in the pipeline behavior, but okay. All right. So then let's go to the detailed design. So here now. So the first thing, as we can see, the two things are different. The first thing is that we need to have a way to change the or select which MAC to use for the ENI to look up the ENI. So how Dash works today is that we basically use the directional lookup and ENI lookup, those two stages. This is directional lookup or ENI lookup, those two stages to find the ENI. So the directional lookup will check the VNI in the incap based on VNI sets the direction. Based on direction sets which which MAC address to use. So in here, the approach is actually very straightforward. Is that if we in the direction in the VNI lookup or direction lookup stage, for each VNI, we will add a new attribute here to specify the override ENI MAC type. So basically like this. So we see the sci ENI MAC override type equals to none, and this one equals to source equals to desk. And with this specified, then we can very easily to say, okay, if it is coming from the MSCE using this VNI, let's use the destination MAC to do lookup instead of the source MAC to do lookup. Okay, and to show how the pipeline works more, we actually also created a PR here to add the ENI MAC override support, and I believe this one is somebody merged the code, so it has a slight conflict. But yeah, it was passing all the CIs already. So if anyone is interested in how it works in detail, feel free to check it out. Okay. And then once we have the ENI selection, which is actually the easy part, the more interesting part is actually how to update the reverse side of a tunnel. Reverse side of tunnel with this source MAC. Source IP. And to show how it updates, actually what happens underneath is that it is more than just updating the source IP. It's actually selecting which MSE we are going to send in the reverse side. So a little bit background. For the return traffic, that needs to roll back to the MSE. So the first thing is that is actually based on the customer's configuration, like which one needs to go which where. It's actually based on the customer configuration. Customer can specify the on-prem subnets, and for each subnet, they can actually specify which MSE to go to. So essentially, it translates to different IP address we use in the destination. And then the second thing is actually MSE will sometimes it will fail. So in this case, we will need to fail over. And in the failover case, we'll need to update the reverse tunnel to the new configuration. However, there's another interesting thing is that we in a flow resimulation, what we usually do is we mark this use some way to mark a flow as needs to be resimulated. Then the packet, when next packet comes, it will go through the entire pipeline, get the latest policy, apply to the flow as a whole. That means that all the not only the reverse tunnel, this tunnel is changed, but also the forwarding side, everything is also changed as well. And then breaks private link, because the policy could change in the middle. However, the connection that is already established, we need to maintain the transformation. If this transformation is changed, let's say the underlay is changed. The underlay, for example, destination IP is changed or whatever, and then we'll send to a different endpoint, and then different endpoint may not have this information, and the connection will break in the middle. That means that anytime we update it, everything will break. So we'll walk through those two cases and explain how to handle those two cases in the Dash pipeline. All right, so that's basically the background. Let's first check the easier one to select the MSE. All right. To select the MSE, what we can do is that we can leverage the similar concept as reverse path forwarding, which basically checks the source IP during the forwarding path. So how it works is, in this case, what we could do is then we will add a reverse sorting stage in the Dash pipeline, and but unlike the regular routing stage, which is actually here, unlike the regular routing stage, it will be like controlled by using the routing type. We can say, oh, it's coming to the routing, it's coming to the VNet mapping, those things. This reverse routing stage will be executed like by default. It will be executed by default at this moment. So it's not involved in the transition. Then, before the action apply. So, but implementation-wise, it's actually okay. We can like shuffle it based on the underlying like the implementation, but just concept-wise, well, it's by default to be executed. Then, if no route entry is being hit, then preferably we should not drop the packet because it just updates the reverse tunnel. If it's not hitting anything, we just continue to later stages. All right. Then for how the detailed implementation is that in the reverse routing stage, we'll have a reverse routing group, and this one will be almost the same as the forwarding side of the routing group. So we'll have the disabled this. So this one is the same. On the ENI, we'll have, so this is ENI. We'll have a reverse routing group ID. So this one is also the same. Then for each routing group, we'll have a few entries. So of course, the first thing is that we'll have the routing group ID as a first entry to specify which group we are actually in. Also, we'll have a source field to specify the source IP prefix. So this is essentially a LPM lookup, and that's pretty much it. And the action will be much simpler than the forwarding, like forwarding side of a routing group or router entry, because it only cares about reverse tunnel. So the only thing we need to do is actually reverse tunnel ID, as well as the flow resimulation support, which maintains the PC. We'll explain this part later. And so besides the route group, now we have the reverse tunnel ID now, and to find the next hop, the reverse tunnel can contain multiple next hop. So it will be used as an ECMP group. So in here we define the reverse tunnel table and entry as a separate one from the forwarding side of a tunnel table entry. So this one makes the API clean. It also makes the P4 easy to support. If any implementation uses the P4, then you have some limitations, says that every table can only execute at once or something like that. So with this table like splitted, then we can easily like support in any architecture. But if anyone support like one single table to be executed twice, then we can like feel free to arrange accordingly. So then it's totally okay. All right. So the reverse tunnel table. So this one will have a few common fields that is shared by all next hops. And for example, the encapsulation and the tunnel T. So those two things are really like having will be different for each next hop. So they will be put in here. And then the next hop object will have a deep and stick. So this changes destination IP and changes source IP. So this one, this one is how we update the source IP in the pipeline. And then use to create the tunnel and the next hop connection, we will also having a tunnel reverse tunnel member table that creates a tunnel ID and next hop ID connections here. So this design is also follows the like the same design as the forwarding side of the routing type, as well as the side next hop design. So it's exactly the same concept. All right. So this is how we select the MAC device based on the route. Here, based on the IP prefix, the subnet on the on-premises network, and also how we changes the source IP. All right. So that's how we do the MAC selection. Then after this, how do we handle the failover, as we talk about? So the two things we need to do in the failover case is that first thing is we need to update we need to update the reverse side of tunnel. Second thing is that we need to maintain the forwarding side of the transformation. And those two things seems to be conflicting with each other, and this makes this design slightly interesting. But gladly, in the dash, we already laid a good foundation on the flow resimulation support. So we'll just use the same flow simulation mechanism to get this working. Okay, so the first thing is the reverse tunnel update. How do we do that? Is that basically what happens because this is a row table, and row table will have an overlap, and in the flow resimulation design. So let's open it up. In this design, we have a few type of flow simulation, and this one falls into the full flow simulation category. So it's echo or roads that will have some overlapping. So this one falls into this category, which means that in here we'll use the same mechanism. So to update that, we will do it in two steps. It is still an explicit flow simulation call. So the first step is that it updates the deep list. So it basically updates the deep for the every single next hop. Then the request of full flow simulation. This is what we call explicit flow resimulation. And then use this one. It will cover like all the existing flows, update everything in the flow when the next packet arrives. Okay, and then with this the reverse side of the tunnel will all be updated. However, the next question is then how do we maintain the forwarding side of the tunnel? That is this section, like how to maintain the per connection consistency. And so in this case, what we could do is that we can use the flow resimulation API. It's called flow resimulation scope. And sorry, this private link. Here, there is a flow resimulation scope control. And this scope control defines, or if you see anywhere it says routing action disabled in flow simulation, so this one defines what kind of routing actions that we need to avoid being resimulated in the pipeline. So conceptually, we are using the same thing. And so in this case, we'll have the, for example, the PL and PLNG. So in the PL, we'll have the static incap, and 46, we'll have these two specified in the disabled flow resimulation scope. Basically, in the corresponding field, we ended with this, but not in the reverse routing, of course. Yeah, it will be in the CAPA entry here. All right, and then for the TSG, so TSG will have another extra action. So it basically adds a tunnel on top of that. So we'll specify the tunnel for the PL NSG to avoid like tunnel being resimulated as well. So with this, that is basically everything that is covered, that is needed for the express route gateway bypass. So is there any questions so far for the design?
I have kind of a
go
basic
ahead.
question, maybe that is obvious or should have been obvious a while ago, but is it correct that so this Resimulation API is, I mean, the flow cache is a cache, and it would always, I assume, be correct to just erase the entire cache and rebuild it based on arriving traffic. That would always result in correct behavior. It just might not be as efficient as keeping some of the cache around. Is emptying the cache always correct?
Sorry, what is in the cache? Probably didn't.
So the flow the cached result, the reason why you do a flow resimulation API is because there's something in a cache that's wrong. Needs updating, right?
I see. Yeah. So this cache is actually a flow table.
Right. So emptying the cache would always be correct, just maybe not efficient.
Yeah. Empty the cache. And so empty the cache. Let me think. I remember like this one. If we just delete everything in the cache, it may not be ideal. It may not be ideal because, for example, in this case, like for the private link case, if we delete the cache, then or the flow table, if we delete all the flows in the flow table, what happens is that we lost the previous like decision. So if the new packet arrives and going through the pipeline, you may end up with a different tunnel, like different underlay tunnel, and then could break the connection. So it's not really a cache, and or is the flow table is not should not be like wiped out because it's not really just a cache. So it's actually
so there's some information
storage. Yes.
There's some information about currently open connections you want to preserve, but other information that is now invalid, now out of date, and you want to update.
Yes, exactly.
So it's partial cache invalidation, not full cache invalidation that you want to achieve.
Yes, and that is the resimulation scope. Then is to achieve the partial update. So this one,
So the tricky part of cache invalidation, partial cache invalidation, is figuring out the portion that's correct to invalidate and the portion that you want to keep.
Yes, and that's why we are leveraging the routing action concept here.
Okay.
To specify which part we need to validate.
Okay. No, thanks for that. I mean, in many cases, completely invalidating the cache is always correct, but in this case, effectively there's some pinned flow state that you want to keep around even on. Okay, thanks.
No problem.
I had a question in the chat, Ref, and maybe I missed it. You said, go ahead. No, I probably missed it. You said at some point and then we can choose the MSEE that we want to use or go to. How do we know how many there are, or like the array of MSEEs, or is it some sort of discovery, or
Oh, I see. So how to where does those like the policies coming from? Is that still coming from the SDN controller? So in this case, let's go to the routing group. There we go. Yeah, this is the routing entry.
Sorry, guys. Yeah,
no problem. So let's say I created the network. Okay, and I have like 10 subnets over there. So what happens is that we'll have a 10 routing group entry with 10 different subnet, and each subnet points to a different reverse tunnel ID.
Okay.
And then reverse tunnel ID will have a different zip and different zip. And all of this information is pushed from the SDN controller. So
Thank you.
No problem. All right. yeah, I think that's pretty much it. And I probably will update, do some like minor update in the HOD. But that's pretty much how the things works in high level.
Thank you. And so, about how long do you think this HLD will stay open? Like, are we looking for like a 1 month review time or a 2 week or
So.
Or we just never know?
Not really. So I think so this one so internally we have all agreed. So that's not a big problem. I think as long as like I have already send it to Mukesh and Marian. So as long as we have approval, we can get it in.
I'm gonna mark that as in process then, or awaiting review. I'll do that. That's awesome.
Sounds good.
Yeah, that's really interesting. Go ahead, sorry.
Sorry, Riff, I had a question around the resimulation thing, right? So with NSG, you have the extra end cap of the tunnel, right? So even that is subject to a resimulation event if there is a change, is it? That's true, right?
Yeah, so that's basically just the tunnel. So we will specify it. However, be aware one thing is that usually when PL in a private link, oh come on, yeah, the fast pass will kick in. The load balancer fast pass will kick in. So whenever the fast pass is kicking, and the packet will be directly sent to the fast pass, like the endpoint, right? So it will be, ouch, my machine is pretty slow, but it will be like using the flow redirection directly sent to the endpoint. And in that case, the flow resimulation doesn't apply anymore. Okay, so after fast pass is kicking, then flow resimulation will not like take effect anymore. However, if fast pass is not kicked in, then we need to preserve that. That makes sense?
Yeah, it does.
Yeah. Okay, sounds good.
Thanks.
Any other questions, guys? Or go ahead.
Yeah, this is Christian. Sorry, I'm new to all this, so I'm excuse the stupid question if it is one, but even in FastPath, can't you have the flow fail if the endpoint for the redirect dies?
This is actually a very good question. Yes, this is actually a very good question. Yes, we need to cover that. And then it means that the fast pass, because fast pass only care about forwarding, it doesn't really care about the reverse.
Exactly.
So I think we need to update HLD to get this like clarified. Yes, thank you. This is a really good question.
Thanks, Christian. Christian has a lot of SLB experience, guys. Just FYI.
Very good.
Yep. Any other questions, guys? Well, thank you, Riff. That was awesome.
All right. Thank you.
Yep. I'll go ahead and steal the share back if that's okay.
Yeah, I already stopped the sharing. Thank you.
Yeah, no, thank you. And I'll go ahead and cover, it looks like we had a contribution from Mukesh from AMD here, and it looks like we just corrected an attribute name, so it looks like we had a merge there. Hopefully no questions on this one. Looks like it was just changed in YAML1.py. Okay. And then other than that, add reverse routing table. Oh, Riff's got another one. Okay, and reverse tunnel support. So this was what you were talking about, Riff? The other PR?
This is the P4 implementation. Yeah. If
Got
anyone
it.
is interested in how it works like internally, behavior model wise, then this will this can serve as reference.
So this is the P. Okay, so mark that in progress. And then we have back over. Yep, we talked about this one. Okay, great. So we had a couple that were waiting for review. This one here. Riff, did you get a review from Marian on this one? The refactoring coming packet
Marian
and
is already signed up. Okay, perfect. Thank you.
Oh, has he? I don't know.
Yeah.
Oh yeah, looks
because
clean. Okay, got it.
Yeah,
Looks clean.
yeah.
Okay.
The
So that
recent
one.
updates, there's slightly a few updates over there. I'll resolve the conflict.
Okay, great. And then so this inbound routing question, we were trying to remove this from our documentation because according to Ashutosh, it wasn't needed. I suppose can someone go through and look at this, or I think I tried to remove it. I guess I'll ping Prince or Sushant to take a look at that one.
Yeah. Christina, do you
Yeah.
mind to like keep this one for a while?
Keep which
because,
one? The inbound routing?
source IP. Yeah. Yes.
Yeah.
Because we might discover some cases that this one could turn to be helpful. But
so just leave it.
Yeah. We probably can leave it for a little more while, and
Okay.
we'll come back.
No,
Yeah,
no problem.
you.
No problem. Yeah. And then, Murcha, did you get what you needed for this issue about the overlay desk Mac? I think we were going to retest it or something.
Yeah, I still have to try it.
Okay, no biggie. Great. And then, did we cover this one? So, oh, Murcha opened this one and terminate pipeline when action drop is encountered. We were going to check in with Riff on this one. Do you remember this one, Murcha and Riff?
I remember it, but it's not urgent. It's
not
just
urgent. Okay.
Small suggestion.
Okay, so not urgent. Okay. And then the side challenger tests failing. Did we make progress on that one?
Yes, actually, PL Vision submitted the PR, and I think I linked the PR in here.
Okay.
So it was going through review, but
yeah.
Last time I checked, I don't think it was merged. We can click on it. See if it. No, it's still open.
Okay. So that was dependent on that one. Okay.
Yes.
So what's it called? Got it. And then I don't know if anyone has seen it, but we do have this Smart Switch platform test plan document that's been being worked on. A lot of changes have been generated and pushed to this one. Quite a few, if you're interested. They're still working on the test plan for this. So FYI. And anything else? I think that's about it for today. We have a few in our to-do. So this one needs a volunteer if anyone's interested, but we were trying to change optional to ternary in the list match definition here, and it's going to take a lot more work than just changing the word. So Riff had mentioned to me that's going to take a lot more work. So if anyone wanted something to work on, we have that one. So I'll open it up to you guys. Do you guys have anything Q&A you want to talk about today? Sounds like we went through a lot of information. Oh, go ahead.
Hey, Christina, maybe a quick question, an afterthought to what Riff presented earlier for resimulation. As maybe an alternative to that, would it make sense to, instead of storing the policy in the flow itself, saving those details in the flow, maybe we could just use a pointer or an index to the policy and whenever and store just an index to the policy in the flow table, in the flow entry of that flow, right? And then whenever the policy changes, things are basically carried over seamlessly, because we need to index into the policy reader pointer every time we get a packet that hits that flow, if it makes any sense.
Yeah, hi, Christian. So I think there are two things here. The first thing is that what we are doing in the BMV2 is basically serve as a behavioral model and just like a reference, but it doesn't restrict how the underlying like the hardware implements. So if your hardware actually support doing this type of optimizations, like feel free to actually implement that, and that is actually awesome. The second thing is that the policy could change over time. So let's say we have a tunnel and we are having a pointer that points to the tunnel. So supposedly it should work. However, when tunnel updates, and then based on the hash of the packet, the next packet could end up with a different next hop. So that could break the data path, but it also depends on how you protect those cases. So then goes back is that if the hardware supports that, that definitely will be great. But on the other hand, there are a lot of like details man needs to handle. So the simplest mind model, not implementation, but just a mind model, is that we are saving all the final actions in the flow. That means that, for example, I'll take still take the tunnel as example because sometimes it's just perfect. When we specify, say, NSG or reverse tunnel, we usually specify the ID from the policy. However, then ID could map to multiple things. One single tunnel could have like multiple next hop inside. So in those cases, instead of saving the tunnel ID, we actually save the final in-cap information in the flow, because that will be maintained when the tunnel is getting changed. For example, in the peer, in the private part, yeah.
So basically, I think there are two options. One is we want all the packets from the same flow to follow the same path that was decided on the first packet, even if the policy changes later on. We don't want that to be picked up. So that's option number one. Option number two would be we decide the policy initially, but then if policy changes, we want the subsequent packets to pick up the updated policy. That's option two. Which one is the one that we want in this case? That you
so depends on the scenario. We actually want both. Yes. So it's a slightly complicated. Devil's always in the details. But yeah. But if you have any questions or implementation wise, you have any questions, like feel free to reach out to me. I will be more than happy to answer any of this.
Yeah, thank you. Thank you, Riff.
Yep, no problem.
But not in the next month, right, Riff? Don't reach out in the next month. After 1 month.
If it is possible. If it is possible. Yeah, I will take a vacation on the next month. Need to go back to China, get all the IDs renewed. But yes, I'll be in a vacation in the next month. But I'll come back in a month.
Yep. Does anyone else have items they want to cover? Okay, well, thanks everyone. I can give 13 minutes back and I'll stop the recording. And what I'll also do the normal stuff, publish to the YouTube channel and send out the notes probably by the end.